Here's an example of what your notes should look like for this section 9-4, Solve Quadratic Equations by Graphing. By the end of the video, you'll be able to answer, how do you graph a quadratic equation? Okay, let's recall some important pieces of information. For this section, we're going to need to know the axis of symmetry, the formula that we use to find it from a quadratic equation. We'll need to know how to get the vertex, and what the definition is for a vertex. We'll need to know the difference between standard form and related form. So take a minute and see if you come up with these definitions, and I'll have them in just a second. Okay, here are the definitions. For axis of symmetry, which we also notate as AOS, it's x equals negative b all over 2a. So you remember, you have to memorize this formula because you actually have to use the x value that you get when you simplify, and you use it to help you find the vertex. And just a reminder, the vertex is the highest or lowest point of the parabola. Then we look at standard form and related form. The only difference between these two forms is the 0 and the y. And because we're graphing, we're going to stick with related form. So you'll see me and hear me use this vocabulary term. We will go to standard form starting next week when we solve a quadratic function using alternate methods. Okay, you should take a minute, pause this video, and write down the steps needed for graphing a quadratic equation. And it only takes 3 steps. The very first thing you need to do is you need to check to make sure the function is in related form. So that means that your function has a y equals ax squared plus bx plus c. Okay, has to be in related form. Then you're going to find the AOS and vertex. After you find those two components, you want to plot them on the coordinate plane because it helps visualize your parabola. Next, step 2, you'll make a table of values using x values to the left and to the right of the vertex. So it will be 2 values less than the vertex x value and 2 x values that are greater than the x value for the vertex. And then the third step, you'll plot points and connect them with a smooth curve to form your parabola. And make sure that you cross the x-axis because we're going to have to look for the solutions in the next video. Here's our first example, and we're going to complete 2 of them. We're going to graph a quadratic equation. So I want you to remember the 3 steps from the previous slide, and you should have them written in your notes so you can refer to them. Step 1, and sorry, I need to pause. Make sure that you have your table, your function written down, and your graph written down before we begin graphing this quadratic equation. Okay, now let's begin. Our first step is to make sure it's in, well, not our first step, but just like a pre-first step, is to make sure that it's in related form. And notice it is. It has the y instead of the 0 there, and it's ax squared, or yes, minus 4x or bx plus c. And so now what we're going to do is we're going to find our AOS by using the formula x equals negative b over 2a. And my workspace is really small, so hopefully I can fit everything on here. So bear with me. So now we're going to go ahead and plug that in. We want to identify our a, which is going to be 1. Our b is negative 4. I'll put a little b there. And then our c is going to be negative 5. So here we have negative, and then an extra negative 4 goes on the inside for b, and 2 multiplied by 1 for a. And when you simplify this, you'll get 2 as your answer. So now that we have the x, we're going to plug that into the original function to get our vertex. So we have 2 squared minus 4 multiplied by 2 minus 5. And when I simplify this, I get negative 9. And now that gives me my vertex. So my vertex is going to be the point 2 for x and negative 9 for y. So I'm going to go ahead and write that in the middle of my table, my vertex, 2, negative 9. And I'm going to just box it so we know that that is an important point on our parabola. And I can begin graphing now. And this is all part of step 1. So we're going to go ahead and graph the point 2, negative 9. So 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Just right here. 2, 9. And then my axis of symmetry is x equals 2, which is this dotted line. So my parabola will be split in half on this dotted line, and it's going to have a lowest point of 2, negative 9. Now step 2 says pick two x values that are greater than and less than 2. So you can use the graph to even help you do this. And here, let me switch colors now to notate this extra values that we're going to find. Two numbers that are on the, let's see, on the right side of the parabola would be these 2 points here. So that is point 3 and 4. So we'll use 3 and 4. And then if you want to get 2 points on the other side, so we can use 2 points of 1 and 0. And now we'll plug those into our function and find our y value so we can plot and graph our function. And here we get 0 squared minus 4 multiplied by 0 minus 5, and that equals negative 5. Plug in 1, so I get 1 squared minus 4 multiplied by 1 minus 5. And this is going to give us 1 minus 4 minus 5. And 1 minus 4 is negative 3. And negative 3 minus 5 is negative 8. And because my values are correct, and I'm pretty sure they're correct, I can now go ahead and reflect these points. So this gets reflected here, and I get negative 8. And this is reflected on the other side, and I get negative 5. And the only reason why I can do that is because I chose the correct x values, 2 that are on one side of the parabola and 2 on the other side of, not the parabola, excuse me, 2 on the other side of the axis of symmetry. So now I'll begin to plot these points. So we have 0 and negative 5. So 1, 2, 3, 4, 5 right here. And we have 1, negative 8. Should be right here. Then we have 3, negative 8. See? Notice how that point is reflected. That's the point that I didn't have to even do work for. And then we have 4, negative 5. And now I'll connect using a smooth curve. And it created my parabola. Let's see if I can erase. Yeah, there we go. I'm just going to erase that because we don't really need that in the picture. There we go. Okay, and there's your parabola. Here's our second example, and I challenge you to pause the video, try this one on your own, and then go ahead and begin playing and check your work. Really give it a good effort and use the previous example. But let's go ahead and graph this quadratic equation. So the same steps still apply to this quadratic equation. And our first thing we need to do before we begin even step 1 is make sure that it's in related form. And I hope you notice that it is not in related form, that we need to add 2x squared to both sides. And if we do that, then this 2x squared will be eliminated, and we'll just have the y, and then we'll be in related form, and we're ready to graph our quadratic equation. So we have y alone on the left-hand side. We always put our a term first, which is 2x squared. Then we'll add our 6x plus 2. And now we're going to solve this graph this quadratic. And our first step is to find the axis symmetry, get the vertex, and then plot those points on our graph so we can visualize what our parabola is going to look like. So let's use the formula for axis symmetry, which is negative b over 2a. And we have negative 6. And notice 6 is positive, so I don't have the double negative issue. And we get 2 multiplied by 2. So I just noticed something that I want to change, and I hope you can bear with me. But I want to change one of the a coefficient because I want to get a nice whole number for my axis of symmetry, so we don't have to worry about fractions, because right now I can tell we're going to get a fraction. So let's change a to 3 instead of 2. So everywhere you see a 2 for the a term, we're going to put a 3 instead. So this now becomes a 3. And that means that this number inside the parentheses is now a 3. And our final answer is going to give us -1. So we got a whole nice number instead of a fraction. So make sure you change all the 2's to 3's for the a terms. And those are the coefficient in front of the x squared. So now we have our axis symmetry, which is x equals -1. I'm just going to go and begin to plot that now. So there's our axis of symmetry. And now we'll plug it back in to get our vertex. And we're going to have to plug the -1 in for x. So we get 3 multiplied by -1 squared plus 6 times -1 plus 2. And when we simplify, we get -3 minus 6 plus 2. And that is going to give us -3 minus 6 is -9 plus 2 is -7. When I say it out loud, it helps to double check my answer. So now my vertex is going to be the point -1, -7. And I'm going to go ahead and box it a few times so we know that that is a special point. It's our vertex, and I'll put a V there for a vertex. And we'll plot on our graph. So we have -1 and down to -7. So 1, 2, 3, 4, 5, 6, 7. And there is our vertex. Okay, nice big point there. And it's going to be our lowest point, I could tell, because the parabola will open upwards since a is greater than 0. And now we need to think of two numbers that are going to be greater than -1 and less than -1. So greater than -1 would be 0 and +1. And less than -1 would be -2. Oops, oh, I'm having trouble writing on here now. -2, there you go. -2 and -3. Okay, so we're going to plot these in, and I'm actually going to start with points 0 and 1 at the bottom because they're non-negatives, and it'll be a little bit easier on me. And I also want to erase these circles so they don't interfere with our parabola. Okay, so now we're ready. Let's go ahead and plug in those points to generate our y values. So we have 3 multiplied by 0 squared plus 6 multiplied by 0 plus 2, and that will give us, our answer is 2. And then we have 3 times 1 squared plus 6 multiplied by 1 plus 2. That will give us 3 plus 6 plus 2, and that would equal 11. Okay, and then we'll be able to reflect those points. Okay, so now -2 are 0 and -2 have the same number, and 1 and -3 have the same number. And now let's go ahead and plot our points. So I just caught a mistake. I had paused the video and I was taking a look at it. So let's see. I noticed that when I plugged in -1 for to get my vertex, it should have been -1 squared is +1. So that should have been a +3. So that changes our vertex. I'm so sorry about that. So we're going to make some corrections now, and I think this is a great opportunity for us to learn from a mistake and also double check our work. So here I have 3 minus 6, which is -3 plus 2. -3 plus 2 would give us -1. So -1 should be our vertex. So I'm going to go ahead and see if I can erase this point here. Oh, I can't. Okay, so now we're just going to cross it out. So it's not there. Our vertex is actually at -1, -1. Right here. Let's do a different color too. There you go. Okay, and so now let me double check our 0. That was correct. Okay, we got 2. And then now 3. And that was correct. Okay, so now let's go ahead and plot the points. We have -3. So -1, -2, -3, and 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, it goes right off the graph, but that's okay. That is okay. We'll make the graph work for us. And then -2, 2. And then we have 0, 2. And we have 1 and 11 right up here. Okay, that makes a lot more sense. If our vertex was already down, all the way down there at the end of the graph like we had it before, that would have been very weird. Okay, there we go. That creates our parabola. So we graphed two parabolas in this video. We're actually going to look back at these graphs and we're going to estimate our zeros using the graphs. So make sure that you have two great graphs from these two examples, and we're going to look back at them in the next video. So I will see you then.